This question says potassium chlorate is heated. Heated tells me decomposition. I check my cheat sheet. Chlorate decomposition is a special type where the metal chlorate becomes a metal chloride and oxygen. That's what it says on the cheat sheet. You don't have to have that memorized. So potassium chlorate, potassium's a +1, chlorate's a -1, so crisscrossing. That's potassium chlorate. A metal chloride, so my metal is potassium with chlorine is how it becomes a chloride. I look at their charges and crisscross. And then it says plus oxygen, but oxygen's a diatomic, so when it's by itself, it gets a 2. Balancing this, I have 3 oxygens on the left and 2 on the right. I'm just gonna get them both to 6. And then I can fix my potassiums and chlorines with the 2 there. That's my complete and balanced reaction. Now I can keep going with the question. Let's look at what information we're given. So I'm given 4 liters, that's a volume. It's of oxygen, that'll be important to keep in mind what the volume is of. 100 kPa is a pressure, 20 degrees Celsius is a temperature. So I have a pressure, a volume, a temperature. All the information I currently have is about oxygen, and what they want me to find is about potassium chlorate. So I'm gonna need a mole ratio in here at some point in order to go from having information about oxygen to about potassium chlorate. So if you follow our Stoich rules, find moles, mole ratio, find the answer. The only information I have to find moles are pressure, volume, and temperature. So I'm gonna start with PV equals nRT. For PV equals nRT, my pressure has to be in ATM. So let's convert that first. We want it in ATM. We currently have it in kPa. And then using our conversion factors, the numbers that are at the top of the document here. Oops, sorry. All right, I'm gonna stop doing that. The numbers at the top of the document. So 1 ATM and then 101.3 kPa. So cross multiplying, we end up doing 100 divided by 101.3, and we get a pressure of 0.987. I would not round that to 1 because we know it's not the same thing as 101.3 kPa. So that's my pressure in ATM. We know my volume is in liters. That's good for this formula. The volume is of oxygen. That'll be important to keep in mind for when we want to know what we're finding moles of. Looking for moles, R is 0.0821, and the temperature is 20 Celsius, but we have to add 273. So we get 293. 3.95 equals 24.055. And then we're doing the 3.95 divided by the 24, so we get the n by itself. Again, that is our moles, and it's our moles of oxygen because all the information I had was about the oxygen gas. That's what I plugged in, so that's what I found the moles of. Then I can take those moles and do a mole ratio. What I want is the potassium chlorate. What I have is the oxygen gas. Multiplying my 0.164 by 2/3, we'd get 0.109 as our moles of potassium chlorate. If they want mass, that means they want grams. Grams of potassium chlorate equals moles potassium chlorate times the molecular weight. So potassium is 39, chlorine is 35.5, and then 3 times 16 for the oxygens. We get a molecular weight of 122.5, and therefore 13.35 grams, depending on where and how you rounded. Anything like 13.3, 13.4 would be fine.